Good morning. Good morning, everyone. All right. I had some success and wanted to share but also document. But you know how this rolls. We end up having I've rejiggered all my stuff here. So no better way than to finish getting all this configured in situ. All right, and yeah, wow. I really apologize for the I apologize even more for just what I just did right there with the camera. Okay. I wish that I could not show my preview on the streaming window. Whatever. Okay. Where did my chat go? That's not the real chat. That's the old chat. I need the new chat. Okay. I'm still really kind of in my first cups of coffee. This is still a bit of a poor lighting job and also my face. But let's see, where did my remote go? This way, in theory, I don't have to actually touch the camera. But let's see. Oh, look at that. And it's not even focusing. Okay. Problem is that is not well lit, I guess. And also, maybe I don't understand my camera. I got the better camera on right now, but it's definitely having some issues. Anyway, so this is the first assembled board that I got working. And thank you, Captain Ron, again, for all your help. Primarily to tell me what it should look like when it's working. And so, wow, I just spent, I don't know, probably 15 minutes just getting this rejiggering everything. Oh yeah, and then I don't have these set as tabs anymore. Hi, well, Jiminy Cricket. Now I need to do something different than I did before. I wish that that's okay. All right, so all I'm going to do is on another screen, or another window that is, I'm going to quit from my screen session, exit. I really should exit these sessions at some point anyway. Can't tell. I don't know, whatever. Let's go back over to here. Let's just do a new tab. I guess, we've had a few things happen that have been a little bit exciting for me. All right. We're in an open IPC Hope I don't bump the camera. Yeah. All of this is going to get figured out one day, I guess. You know, with like a proper studio and stuff. And multiple cameras and all sorts of craziness. Let's do that. That would be fun. You know what? I just realized I didn't even change the name of the stream. So we're going to do that really quick. First of all, it's the 18th. And also, this is booting first PCBWay Teacup. Sure. And then there's like a share button, and I'll copy that and just show you something else to look at for a minute. That was Captain Ron giving me what he had experienced in the past when he used the flashing tool. I'm going to admit I did use the Windows tool. Yeah, okay. I at least name it's the correct everything. All right, again, good morning. You know what I really want? What we should do is, here, I'm going to take out the Discord. This is where I get myself in trouble, really. But let's see. We really don't want too many layers, but let's do the capture device. Add existing. I'm going to do overhead. Right? That's our overhead. I know, I need to get it lit better. Here, maybe if I just even turned on this light over here. I wonder how well that changes the situation. Okay, but in reality I want that to be down here. And I'm going to take myself off. Oh, well, that's pretty dark. That's the problem. Okay, well, anyway, I promise I'll figure that out another time. All right, so we're here at the Open IPC prompt, but what I did is I need to collect my thoughts here for just a second. Just 1 second. Not to mention, I mean, the stream's just going. It normally takes people like 30 minutes anyway to show up. Oh, I have maybe somebody or somebody's on. All right, stand by. We're gonna get this. All right. I need to learn better how to show and not tell. Okay. I was really trying to get on to do this. I was trying to just do this stream so that I can document me getting this set up. Okay. And I just remembered now why we're at that prompt for OpenIPC. So I'm going to give you a little bit of backstory, more specifically for myself. This is my browser window. Figure like we could probably make that bigger. This is the wrong one. Get it together. This dude. And I'm going to move my... Got a lot of windows going on here. I super apologize. Okay, we've been using the USB cloner tool. And here's the answer. Hold on. Here we go. I'm going to bring back up Discord and start the story. So, yesterday there was a couple things that I did. Okay, number one, I did this little video of us. I did a lunchtime break where I got Zork working. I compiled it on my desktop and I transferred it over, and I was using the hand assembled board, not one of the new boards. I got a good cadence of being able to transfer files, whether it be to move the SD card between my computer, be able to mount it, throw something on, and put it back in, or using DD, I was able to let the I used DD on the history. Here, I'm going to show you. Yep, history, grep. I might not be on the right one. Oh yeah, getting LR ZSZ so that I could do samples. That was where some of the frustration came from lunch. Or no, actually that was way in the early morning yesterday. I was trying to get Z-modem and other kind of serial protocol stuff working. And there was some autoconf and other kinds of legacy issues. And so I'm not going to go into that right now, but there we go. I had some issues with getting it compiled. So I went back to my samples, and this is from the SDK. This is, I wanted to try and get a few of the samples working. I did actually on the board, on the green board is what we're going to call it. We got red boards and green boards. If it's a green board, Captain Ron assembled it, and it and already kind of had vetted it, right? So these red boards were assembled by PCBWay and are the ones that I unboxed the other day, and we're bootstrapping those. So, and I wanted to do it in kind of a specific way that I'll go into here in a second. But let's so these are the samples, and if we go into lib imp samples, no, I think it's the sysutils actually. Sysutils. Okay. I was able to get sample chip ID working. Was able to get sample LED working. However, there's an interesting twist there in that it actually uses something, some power object node out of, I can't remember if it was proc or dev. Okay, but it references something else that it requires a kernel module. So, it's like, okay, cool. And I got the donut working. I already knew that would work. These I am compiling statically at the moment. And then there is Zork, and that was one of my challenges that I wanted to do prior, especially when I was just working with the camera, was to get Zork working, because it's a C application and it's relatively self-contained. There's this data file you have to transfer as well. But if go into the make file, really the only changes that I did was I used the SDK's cross-compile for my C compiler, or my CC. And everything else is the same way that I compiled it on my desktop. So really all I did was I added these flags to include static and archmips32r2, and then I added the cross compile prefix and this GCC. All right, so, and that worked. So, and then, you know, I was able to, here, this is the thing that I need to show you. If I do echo, nope. Okay, well, let's just hit history. Probably going to be able to see it. Well, I'll do it. Maybe I'll just come back. Anyway, the point is that all I had to do was like a base 64, do the file, so like Zork, right, and just send that to dev USB, nope, TTY USB. Wow. TTY USB 0. Brain's still waking up. All right, and by doing that, then it's going to shove in base 64 everything over the wire, where then it'll appear over here. In fact, I could do that now. Zork's a little big, but I'm not going to do it right now. We'll save it. So it's going to echo across here. But if on this side you have something that's like dd in file equals dev, you know, tty s0 out file equals, you know, temp my file dot base 64, then it will sit there like, and you hit enter. It's not going to work here because we're not actually booted into Linux, but it'll take whatever's in on that TTY port, in this case our serial port, and write it into that base 64, or, you know, write it into a file. There's a whole bunch of different ways to do this, but this is the way that I was doing it because of minimal tools and that sort of thing. And that works. Sometimes you have to do it twice because there's not a sufficient amount of like error correction, or it would overload, but still, it works. I decode the file and set the execute attribute, and then it works. You know, and then you can execute it, and that's that's the product. Or the video yesterday is the product of being able to do that. Okay. I wish I could do like inline chapters or changes here. We'll see. But what we're here for today is to boot this guy off of the SD card for the first time. And what I did, I'm not going to be able to show you because it's on this ThinkPad that this Teacup is actually sitting on top of. But what I did is I used the USB cloner tool from Ingenic to load U-boot. And I did take a little bit of a cheater's way to do this, but what I wanted to do is just have U-boot on the flash chip so that I could get there and then put in the boot arguments for booting off of the MMC. And we're going to see if this works. I don't actually know if this is going to work now that I'm starting to really think about it. I shouldn't even have done this stream. Oh well. That's why we do this. Okay, so finished dumping my brain here. I'm going to have to, I'll do a video also on going through the USB cloner tool, which I got from the Ingenic website, or the FTP site, that is specifically. For right now, again, this is a little bit all over the place, but for right now, let's just, you can totally go to, let's put this over here, I guess. You can go to www.hackerhomestead.com. And here is my wonderful little web page. There'll be more on that sort of thing later. But here's my web page. And in it, you can even find like the interactive bomb, which this is way too big right now, right? But you can go to the interactive bomb. You can find my blog and Discord, etc. And then also I have, I have a files directory. In that files directory, we don't have to pay attention to it too much, but I have a DOS repo and some files for the Compact Portable 2, which I have sitting over yonder, and I would be happy to get to sometime. Oh dear, did my, it's the first time using this. Yeah, this image is no longer live. For some reason my camera turned off. Not sure why that camera turned off. Oh. Wow. The show must go on. It's not really important for right now. Oh. Stop fidgeting with it. I can't. I'm obsessed. I need a wide shot now too. Yes, now you have a live static shot again. Let's go back to general. Stop going off on tangents, handy. If we go into files, we have an Ingenic FTP. Within that FTP site, there is a, this is a mirror of the publicly available anonymous FTP site. There's a folder called dev support, and then there's a folder called tools, and there's a folder called USB burner, and there's a lot of files in here. Now, there is a Ubuntu version of this cloner, and there's some nice manuals. There's even a quick start guide right here. Okay, that's great. I used, and so did Captain Ron, on Windows 7. I went through the process of using the cloner, I do believe, cloner latest windows.zip. Now, you also end up having to install the 32-bit drivers. Okay, this is the important part. This this tool is, you know, I don't know if you guys have used these kinds of burning tools from manufacturers before. I'm going to add another source. But here, no, I'll just see if I can. Need the USB quick tool guide. That's what I need. Show you. Quick. Okay. Nobody's here. I'm going to turn off. Maybe I should turn off the chat. It's all right. I'm going to show you some screenshots. So you do have to, here's some of the lessons learned if you're using the Windows 7 version. Number one, when you go to install the drivers, because what will happen is you'll plug in your device, and if it fails to boot in all other cases, such as SPI and SD card, it will go into a mode that is for USB flashing. Oh, internal. Okay, I'm sorry. Again, squirrel. On this shot, for whatever reason, it's giving me internal temperature too high. Whatever. This is shot static at this point, so it's not that big of a deal. Back to the show. When you install this, it's going to come up as a Windows boot device, or I'm sorry, as a flash boot device. And if I was to go into my electronics on Discord, you can see this is what it'll show up as, right? And this is on Linux, but in Nginx Semiconductor, and it comes up as a USB boot device. For whatever reason, this is cropped on. Oh, I see. It's cropped because I was searching. There you go. USB boot device. And and that's what's going to happen. I am an absolute mess this morning. Stand by. That's what's going to happen. Is it's going to show up in your device manager, unknown. You're going to do an install a driver. And this is the very important part when you're trying to find one of these drivers, because there's a whole bunch of files in here, a whole bunch of versions. Went with the latest. I found at least 2 that work, because it's really a symlink to this other one. But when you go to the drivers, make sure that you are at the top of the directory for the driver software. So it'll say, like, you know, cloner Win32 driver or cloner drivers. And underneath it, there'll be like an IA64 and an X86, and there'll be a few different platform directories and that sort of thing, and some, INF files. INI? Anyway. And I'm sorry, I just wasted like at least an hour at least 30 minutes trying to figure this out. You just want to specify the top level of that driver directory and let Windows try and do the rest. Okay, I know I belabored that way too much. And then it's going to come up, and it's just so small. It's going to come up, and this is what you want it to look like: lib USB Win32 device. And then as you proceed, and this won't be for the T31, I'm going to show again my Discord. I'm going to queue up what Captain Ron sent me. This is horrible. I just want to document it. I'll have to go back and, well, I'm going to do this at least a few more times, so pretty sure it's okay. Yes, that is queued up. You'll have a screen that looks a lot like this, and you'll want to go for the config button right here, the config button, and that config button then launches you into a screen. Yep, see, we want the config, and that then launches you into this kind of config screen. And then when you, I'm going to start going a little faster here. When you start going through that config screen, for our lovely processor, doesn't want to zoom on me, for these boards, this is the config that you want. You want the T31, and then for board, T31. Why do I feel like I picked the Z? Oh well, there's a drop down that gives you several board configurations. I think one of the most important things to say is that you're referencing the NOR, DDR2, linux.cfg. This is the baud rate for the console, and this is the UART port that you want. I thought maybe I was on the wrong UART port at first, but I was not. The issue was, I think, a combination of a few things, and I'm just going to skip over it for right now. And then you're able to come to a screen like this, which is under policy. So you're going through kind of these tabs. These are in reality the only two tabs that I and Captain Ron had to do anything about. And by default, it's assuming that you want to, that you're going to create these different, think of them like partitions, right? But it's a NOR memory. So these are really just points in memory, right? Or points in memory locations, ranges. So here we want to put U-boot at offset 0, and by standard it goes to the first 256. Okay, now I guess technically we could have used flash that only had about 256K, because that seems to be the sweet spot. It's the same as like well, nope, I'm just going to move along. You have U-boot, kernel, and rootfs. And I only kept this one checked, so did he. And then you're going to give it a file. Now, what file? Well, this needs to be your U-boot file. Now, again, I cheated. I was trying to just like get up and running to see if the thing even worked. Now, from here, I'm going to give you I'm going to give you the next nugget of wisdom. Okay. So you're going to go through here, you're going to hit save, and then you're going to do save, and it's going to save as a board config, and that's cool. You want to save the current configuration. It's pretty well, I mean, there's some good documents. Like kind of what's going on is maybe not so great, but okay. So now, at some point, you're going to get to back to this kind of looking screen, and I ran into some issues with this lock level. Hopefully you don't get off on that rabbit trail. I've got to find out really what that meant, because then it started asking for passwords, and I don't like that. But this kind of screen is generally representative of what you're going to get, and you have your I think in this case, it's just like uboot, a kernel rootfs or something. There's only 3 of them. And you figure, oh, okay, so if you're like me, what you did is you figured you would have your board connected, and then you would launch this software and you would do your configurations. Maybe it'd give you some validation that it's already connected, you know. For the most part, it does not, just so you know. And then you would hit start here, right? So start, stop. You'd hit start here, and it would go. Aha, no. Thinking about it wrong. This is really for doing things in batch, where you have a lot of boards the same kind to do, the same configuration, etc., and you're just trying to get them flashed. So the workflow is that you open up the app, you do your configurations, you select your thing, which is kind of a staging phase of the workflow, and then you hit start. And then you plug in your board. And then it starts working. And that's the workflow. And then you unplug your board. And in theory, you could plug in another board and it would flash it and it's done. And so you pull the plug and you plug in another board. And it uses the detection of that board, that event, as the point to start flashing. All right. Got a cough. Even if I am the only one that I get that off to in the future, that nugget of wisdom, I need that. I need to remember that order. And a lot of times just the sequence of events that happen, you just need to record them and get them out there. This is a lot like science. Observational science, experimental science. Okay, and I don't remember getting these percentages, but what I do remember getting, and unfortunately, yep, wasn't recording. I'm going to scroll up here a little bit to show you the kind of output that you should expect to see, which Captain Ron said, you know, if it works, you're getting this kind of thing, right? So there is output on the console. And when I had these terminal wires set not backwards, when those were not backwards and I figured out the workflow, it worked. And that was this morning, by the way. Sometimes you just have to rest on it and come back, and it like worked in 5 minutes. This is one of those things, I'm just going to say, particularly the uninitiated manager or managers of engineers seem to kind of forget, is that we don't work linearly, and mistakes that happen, mind you, I was already doing this late at night when I was towards the end of my brain capacity. I save all the really careful work for my employer, right? right now. And obviously I still make mistakes. But point being is that you can have a bug or a flipped wire or whatever, and you could be troubleshooting it for, let's just say, 2 hours. Or you could have a fresh perspective and you come in and you get it done in 15 minutes, right? Let's just say 20 minutes. So it's not really the right factor, but the point is that you could have orders of magnitude. I've had this happen where I was working on a bug, I kid you not, for like 3 weeks. Now, mind you, this was a complicated this was in MuleSoft and was a messaging platform and all sorts of other things that I was trying to figure out. That apparently we had a Heisenberg bug, which is where you the bug only presents itself when you are attempting to debug it. I won't go into that, but the answer ended up being literally to slow down some like rate of transactions so that this other module could initialize. Okay, so I actually figured out the bug in about a day, but it took me 3 weeks to get there. And part of the problem was that I was distracted with all these other things. I was looking at this thing from the wrong perspective, etc. So there's this thing about engineers where, like, you need to not feel bad that you need to take a break, take a nap, do whatever to reset your brain in order to move forward. Because, you could spend 20 minutes doing it, or you could spend 2 to 4 hours doing it, banging your head on the wall. Anyway, sorry, that was a total tangent. So on the story here, I was able to flash U-boot. Now, I need to make sure I document where that came from. Did I make that myself? No. We're still cheating a little bit. We need to get U-boot compiled. Been doing just fine getting Linux compiled. Need to move on to the final frontier of getting that getting U-boot compiled. But right now we're stealing from OpenIPC's wonderful work. So this is what we're gonna do. I just typed in like OpenIPC. Gonna try and see if I can remember how I did this. And yeah, so I just want to get started. What am I going to do? Well, how about precompile binaries? That sounds fun. Okay. So if I here and I have an Nginx. Okay. So hey, docs, U-boot, Linux. This project is so fantastic. I'm going to hit download. Oh, they don't want to just let me download it. They're going to help me out here. So let's say they've got a little configurator. NOR 16 meg. Which firmware version are you going to use? What's your IP address? Network interface. Okay, now none of that's like super relevant except for maybe the size. And then what's your MAC address? I'm not going to do this. See, like you could TFTP. This is designed so that you can like TFTP boot your device. Okay, so then they give us some other very useful information on how we might go about this, booting off of TFTP and backing up our repository. Okay, so if I just kind of go down here and I say, oh, hey, alternatively, I can flash by my parts. And oh, look at this. There's an OpenIPC U-boot binary file. That's what we want. And that's what I downloaded. So I just like clicked it and downloaded it. Yes, that's right. I have no clue. It could be very dangerous. I should probably get the root file system and just kind of like this is, and just go through it like a normal person. I can't believe I just clicked open. Show in folder. Not that it's going to matter. All right. So that worked. And then I put it into this file location, which the attribute is the name of the file, but what you do is you click this settings button. I know I'm all over the place. And then it brings up a file browser. I definitely want to try this with you, Linux instead. But I don't know. I might clone all the. I might clone all these with it in Windows just to kind of like. What would I do if I was? I don't know. a different person. No. The point is that I got it working on this system, and this is like the thing that you do at the factory. Although, because then in theory you can, well, you could self-serve on the device after you got it this far, if you just get the bootloader on. But I understand we all need to be able to load our own bootloaders. They provide a tool. I would like to use it in Linux, and then I think we have some inroads into helping extend a project that exists already that is open source for doing this. This reminds me a lot of the flash radio flash tools that I'm gone to. So let's just pretend that we got this far and we got to 100%, and now what's going to be happening is your device is on your console, right, is going to be flipping through and let's see, I'll reset it. It's going to be flipping through and doing this kind of thing, right? Well, in this case, I went ahead and I put in the SD card. I didn't do it at the exact moment, but it's flipping through, and I said, oh, this is great. So I did Control-C, and pretty much you just have to hold it down. Let's see if I can, now that you just have to catch it. I don't know why. I guess we get 1 second. I did this before because you guys just saw it. Oh, on the wrong one. Okay, so it's flipping through. It's flipping through the boot. I'm gonna see if I can catch it. Also, to make sure my serial line is in there. Okay, I stopped it. I need a switch. And I'm just going to hold down on Control-C. Yeah, I got it. I held down on Control-C, and it worked. All right. Now we're in OpenIPC. If I do a print env, I can see my runtime variables. And the one that we particularly care about, I do believe, is the boot command. I'm going to do this manually the first time using the instruction set that was given to me, and it is actually also on my blog. Okay, we have the SD card inserted. This is when you would insert the SD card. Now I'm going to paste this in. We're going to do the fat load. All right, that's a good sign because it's reading from the SD card. And then I'm going to set these. I'm going to set the boot args. I can't remember if I've done this on video. Oh, well, I have done it. It's just it failed. Okay, this is not pasting. I don't have the keyboard. Keyboard's not responding. There we go. Sorry, I haven't soldered these in, so it's a little touchy. Okay, so we're setting the boot args to point to the MMC and setting the console, and now this is the location we're going to boot from in memory. Everybody ready? First boot. And it worked. And Teacup. password. And here, I'll do uname-a. And this is the same one I was running on, this is the same one I was running yesterday with Zork. Tell you what, let's do, I don't 100% know what that chip ID does. Now that I have multiple pieces of hardware, I can check. So we did chip ID. That worked. I could play us some Zork. I'm not going to do that right now. Yes. And we can run donut. All right. Oh yeah. Well, that was all fun, but what happens if we reboot or I reset this? Right? It's going to go back into this loop because it's looking for something. It's looking to boot off of the flash memory. So I'm going to hold down on Control C and see what happens. Yeah. Okay, cool. That worked. Now what I'm going to do, again, not that my blog is a how-to. I'll have to actually make some. This is all inputs towards a how-to. The raw material. I'm going to save some of these values. So now this isn't going to have any history, but I can do. I'm going to set my boot args. This is technically the expanded version. Okay, this is the expanded version. That we're dividing up our memory, our 128 megs of memory, 64. I guess to the operating system. Well, 64 reserved, and 64 for the OS. I think is the way that works. Oh. And in this case, what I have to do, I did it wrong. Because it actually kind of needs to be in quotes. Just copy and paste it. All right, so setting that environmental variable just like on a router to not save it to flash. So I'm going to do, that's going to hold in memory for a second. And then I'm going to set the second env, which is boot command. Okay, now if you're doing this, lesson learned, if you're doing this and you try and set the env but you don't use these single quotes to quote the boot command, it will go ahead and execute it. And that will keep sending you into a feeling of I succeeded because my thing successfully booted. However, again, you didn't save them, so it'll exit before you get the chance. So now we're going to do a save env. Okay. And in theory, it's now written to the flash, and I think we do a reset. Or I can say boot command. Nope. Do you believe that that was the right? To do boot, it'll call boot command. And look, we're in. So, I'll log in again. I'm going to type reboot. It's auto booting. Now we got to make sure we show what happens when this breaks. I am, however, going to just turn this off here. Oh, this is, we need to fix this too, but not a big deal. I'm going to type in, let's do init 0 this time. No, it doesn't want that. I'm going to do halt. Yeah, that's going to, I believe, send us into a reboot. So I'm just going to unplug it. I just unplugged it, and I'm going to plug it back in, right? So we're going to be booting from cold boot. All right, y'all are quiet this morning on the chat, which is just totally cool. I don't really intend for anybody to see these anyway. I mean, like, wow. So a lot of this is for my own documentation. All right, so that worked, right? Oh, except it's not taking my keyboard. But that is, I don't believe, the problem of the, I don't think I broke anything. Let's try it again. I think my issue is that my UART is not well connected. Nope, it's not working. I'm going to reset this. Yeah. Okay. So I'm just holding it. There we go. All right. And now we're following kind of the routine that I wanted for boot. I'm going to do no, I don't know if I want to do anything else there. Oh, I remember. I'm going to be super, well, that's the thing. This is cowboy, but I'm going to be a hacker about it, honestly. Okay, so I am unsure. Okay, if we go into the Teacup bomb and we recall that this is the part. This is the place where we had the pad snafu. And I need to look into it further because I don't want to be a total, I don't know, a total hack. But I plugged in a board. That I had not modified, and at least it came up from on USB. And so, while I firmly feel that this transient, I think it was like a transient voltage diode, is important, it seems to be unnecessary or not required for functionality as long as you don't have crazy voltages, I guess, coming from your USB device. So this is probably where, if Bogdan would probably get annoyed at me, or not annoyed at me, but he would wag his finger at me. But I'm gonna flash the next board without adding this part and just see how well it operates. I mean, like, I can always add it afterwards. But there you go. So I guess that'll be the cliffhanger. Will this work without having this diode in place? And it probably will. It's just that, so I looked at that and I go, oh, no, those pads, they go right through, so this probably isn't a big deal. And then I went and said, oh, but guess what? If you follow this up, if you follow this lane up, it goes straight onto the SoC. It's the expressway to the SoC, which does mean that, and we've got these test pads here, I guess, for, I'm pretty sure those test pads are for D- and D+, right? This is the data plus and minus lines. And so, that's pretty raw, right? If I don't have any kind of conditioning there. But technically it should work. It's just that you are likely, here's the thing, I don't know how likely I am to blow it up. I think with, so anyway, the other thing that I did was, the other modification is that this R0 was populated, both of these are populated because I need to learn how to use KiCad a little bit better. And they were both populated at the factory. No problem. Was able to make quick work of removing that resistor. So, well, I'll tell you what, I think that's about all I have for now. And let's see, where are we at? We're at an hour. So I'm going to go ahead and stop. If anything else interesting happens, I'll probably fire up another stream or try and do some more recording. But, anyway, there it is. This board is functional. I was able to write to the flash, was able to at least do the same tests that I was able to accomplish on the other device, the green board. With that, I'm going to say, if I don't talk to you before another time today, happy hacking. Thanks for coming along for the journey. And I can see that I had at least 7 folks drop in. So I appreciate. Oh, dadgummit! Well, now there's chat. Now that I'm winding down, let's see who said hi. It's Zach. Okay, it is ESD protection. That's correct. It's ESD protection. Okay. Yeah. So it's passive ESD protection is what I think I'm going to call it. It's passive ESD protection, as in, if it's not there, or if it's not working, you won't know. It's not like a fuse, right? Or anyway, the point is that, and I guess it's for transients, so those are a little bit harder to, to my understanding, this is essentially acting as a filter. And this is my problem, is that I don't actually know whether it's working or not. And I yeah, so I think that's the thing that I don't like about the design, is that I actually don't know whether it's working or not, and I'm inherently a skeptical person. So anyway, that's just part of us learning. I don't know. I guess we're all learning and then have preferences. This is also probably why, so for an electrical engineer, they have no problem with this, but then I am over engineering leaning. Yeah, it's like two Zeners. And obviously reduces the count. Now, what I also don't know is that if this is, we'll have to get somebody on to do like we did with Broke Down that one time, right? Maybe we could get Bogdan on, or another either electrical engineer or somebody that's more current with this than I am. Uh, but I'm gonna guess again, since it was at least described as transient. I'm gonna guess that the fact that it's connected to both pads, there may be some like coupling type reasons as well. And what I'm thinking of is frequency and other, the messy stuff that happens down at the bottom of how you do power conditioning and signal, I guess, signal conditioning and filtering. I'm probably making too much out of it, but pretty sure that's what is happening here. And yeah, I don't know, both of those maybe go into ground and they are actually just like having two Zener diodes. That's probably true. But then why didn't we do a resistor array for R4 and R5? It's all these things. No, I'm sorry. I'm picking now. Inappropriately. I am off base. I need some more coffee. All right. Well, thank you very much for for showing up, and Zach making a comment. I am going to go ahead and sign off. I'm going to say happy hacking and good day.